Hello everyone, and welcome to Office Hours with the Meter Environment Team. Today's session will focus on soil texture analysis with our experts Leo Rivera and Shaun Weldon, whom I will introduce in just a moment. But before we start, we've got one housekeeping item. If you're watching this video and you think of a question you'd like to ask our science experts, we encourage you to submit your question on our website at metergroup.com. Someone from our science and support team will get back to you with an answer via email. All right, with that out of the way, let's get started. Today, our panelists are research scientist Leo Rivera and product manager Shaun Weldon. Leo Rivera operates as a research scientist and director of scientific outreach at Meter Group. He earned his undergraduate and master's degree in soil science at Texas A&M University. There, his research focused on the impacts of land use and landscape on soil hydraulic properties. He also helped develop an infiltration system for measuring hydraulic conductivity used by the NRCS in Texas. Currently, Leo leads Meter's collaborative research efforts and focuses on application development in hydrology instrumentation, including the Satro infiltrometer and the HyProp. He also works in R&D to explore new instrumentation for water and nutrient movement in the soil. Shaun Weldon is the product manager for hydrology instrumentation here at Meter. He earned his bachelor's in environmental science from Western Washington University and his master's degree, also in environmental science, from Washington State University. During the 11 years he's worked with Meter, he's worked in R&D, product development, and now product management. All right, thanks for joining us, you guys.
Glad to be here.
Okay, let's get started taking our questions. And our first question today. All right, they are asking, why do I need to analyze the texture of my soil? Super basic question here.
All right. Well, it's a good one to get started on because why are we even here? But there are many reasons, and I'm not going to be able to cover all of them. But most importantly, I mean, that's your starting ground for everything in terms of understanding your soil. Soil texture is one of the core pieces that we need to understand when it comes to most soil and agronomic and environmental related questions that have to do with how things grow, behave, what the soil does. Yeah. It impacts a lot of things from hydrology to water retention to even nutrient retention, especially as we start dealing with clays. I mean, there's many reasons. I'm sure we can think of plenty. I don't know if you have any other thoughts, Shaun.
Well, I think one of the neat things about texture analysis is it's not just related to agronomy or just related to engineering. It covers all of the disciplines that people might use these instruments for. So it's important to everybody.
Yep.
All right. Next question. What methods can I use to do soil texture analysis, and what are the pros and cons of each?
Okay. Well, we probably don't have the time to get super in detail into all of these methods. We do have a webinar where we cover a lot of these methods. And I highly recommend that you go watch that where we get a little more into the details. And we probably can post a link to that in the description for this video. But just to cover the basics, there are kind of three fundamental ways of looking at soil texture, maybe more than that. But of course, you can do it by hand, right? You can texture by hand, and there are ways to do that. And for those of us that have soil judged in the past, we get pretty good at it, but it is something that you have to learn and takes practice and is not going to be super accurate. And then there are tools that are based on Stokes' law and how depending on the size of a particle, it's going to fall out of suspension at a different rate. And so we have tools like hydrometer, pipette, and tools like the PARIO, which we'll probably dive into a little bit deeper, that we can use for that. And then we have also optical methods like laser diffraction, where we use those tools. And there are some other optical methods where we look at things like visible near infrared and some of those other things. But yeah, I don't know. Shaun, what do you think are the pros and cons of some of these different methods?
Well, I think anybody that's done pipette or hydrometer methods, you know some of the cons there are you have to be there all the time. You have to read it at very certain times. You have to make sure that you're reading it accurately. One of the things that I don't like about those methods is that there's a really high risk of human error in the readings, whether it's timing or even just reading the lines wrong. And so that's one of the big cons of it. The pro is it's cheap. You get the thing once and it's easy, but you need somebody that's trained and knows what they're doing to get really accurate results. As far as like the laser methods, those are pretty accurate, but they're very expensive.
Yeah.
The equipment's very expensive. You use a very small sample, so it's easy to get something that's not really representative of your soil type. So that's the con of that one. As far as the PARIO goes, it's super accurate. It kind of takes out that human error part that we were talking about.
Yeah.
And it also, you're not measuring it based on what you're looking at. It's a very, very sensitive instrument that's measuring it automatically for you, which is really nice. It's more expensive than a pipette or a hydrometer method, but I'm maybe biased, but for me, that increase in accuracy and reliability is worth the price.
Yeah. Another thing that I really love about the PARIO method and compared to some of the other methods is that you get a full detailed curve of your silt fraction, which is hard to get with the other tools. You can do it. Like you can do it manually with like the hydrometer or the pipette method, but it means you're taking a lot of measurements to get to those points. A con with all of these methods, except for the VisIR maybe, or even VisIR needs pretreatment of some sort, is that you have to pretreat your samples.
Yeah.
And that part stinks. Sadly, there's not really much we can do to get around it.
Right.
But that definitely is a con. But yeah, there's a lot of literature about these methods, and we go more into detail about some of the pros and cons of all these methods in that webinar. So I highly recommend checking it out.
Yeah.
All right. This next question here. Can the PARIO be used to determine particle size of silt in stream samples?
Yeah, that is a really good question, and not something that any of us have tested.
Yeah.
I understand the concept, and I know that we use similar principles, like you can use a hydrometer to figure that out. But my concern is that depending on the amount of silt that's in suspension is that it might actually be too small to even detect with the PARIO.
I think with the PARIO Plus, you're going to have a better chance than you would with the older methods.
Yeah.
Because you do take that small sample and weigh that in the oven to get those particles that are still in suspension. But I worry that you'd be using such a small amount of those silt particles that it would be easy to introduce a lot of error in those readings.
Yeah. Yeah, it might not be the best application or best tool for this application.
Yeah.
But hey, prove us wrong. I'd love to if anybody goes out and researches that and actually tries it out. I'd love to learn about how that experience went and if it actually worked. And if that's the case, we can definitely work together to learn more about how to actually use these tools for that methodology.
Yeah.
Okay. This next question is asking, how accurate does a soil texture analysis have to be? What are the consequences of a less accurate analysis?
It's a good question.
Yeah. The first thing that comes to my mind is how accurately do you want to understand what's happening in your study area?
Yep.
I think that getting a general picture is good for some things, but for most applications that people are going to be using, they're going to really want to know, I think most importantly, how water's moving through there, how nutrients might be moving through there, and how well plant roots are going to be able to get through this soil. And so the more accurate you are, I think the better.
Yeah. Yeah. I mean, it always ultimately comes down to what your research goals are. Yeah. And so I don't know if I can tell you specifically how accurate you need it to be. It's really up to you and your research goals. But ideally, we're going to use the best tools possible to get an accurate measurement. And I would say 7 times out of 10, you're probably going to want to try and be as accurate as possible with your measurements, because, a 3 to 6% error in your clay content estimation potentially could be significant depending on what you're doing, and especially depending on the soil type that you're measuring in. So, choose wisely.
All right. Next question. In what situations would I need to complete soil particle distribution curve versus being able to get away with a partial one?
Yeah, that's a really good question. To be honest, I don't think people fully understand the value yet of having a full particle size distribution curve. Now, people often just look at soil texture in terms of what's my percent sand, what's my percent silt, and what's my percent clay. But in reality, your silt fraction's a wide range. Your sand is also a pretty wide range. And for example, if you have a lot of very fine sands in your soil, they often tend to behave more like silts than of course a coarse sand does. So understanding that actually can be really valuable, especially when you're trying to understand physical and hydrologic processes in your soil and how the soil is behaving. So there's a lot of literature that's coming out that's showing how useful a detailed soil particle distribution curve can be. And so I think there's a lot to be learned about what we can get out of it, just like we're learning more about soil moisture release curves. So obviously a lot of people are going to be fine with just sand, silt, and clay, but I think there's a lot of value in it.
Yeah, and I think it kind of goes back to what you were talking about earlier of having the most accurate data, having that most accurate view of what you're looking at. Because if you say sand to one person, somebody's going to think like playground sand, it's very, very coarse. And when we're looking at some of these, like you're saying, it really does behave differently than that. Because it is such a wide range.
Yeah. So, the more it's always think about it like this. You can collect this information and have it now. And it's a lot easier to have all that detailed information and maybe not need it. But if you're in the future, you realize, I need that information, but I don't have it. It's a lot harder to go back and get it. And you might learn more about some of the different research questions that you're looking at just because you have this information. So anyways, I think it's important, and we're learning more and more every day about the actual importance of a detailed soil particle distribution curve.
All right. This next question is asking about applications. So they're asking, would a grower need the accuracy of a PARIO, or would another method be suitable? What applications is the PARIO well suited for?
Great question. It's hard to say from a grower perspective if this is something that they're going to need. But I would say from the consultant perspective, if I'm working with a grower, I think it's important to understand this a little bit more deeply and have this accurate, have tools that are going to be more accurate and give you more detailed information.
Yeah.
Because again, even in growing applications, these small subtle differences can make a difference.
Yeah, especially on a crop that's very sensitive to, say, for example, drainage.
Yeah.
Something that needs a really well-drained soil. If we go in there with something that's not as accurate and we give a soil texture that might not be that accurate soil, the plants and the crop yields can suffer quite a bit.
Yeah.
So I agree. I think it's really important.
Yeah. I think the PARIO is well suited for several applications. Mm-hmm. I'm a soil scientist. And so of course the PARIO is well suited for the work that we do in soil science, from looking at, doing physical analysis of soils, and then using that to understand some of the hydraulic properties. It's also well suited for engineering. And getting all that information. Like you said earlier, Shaun, there's just so many applications where we need to understand this information. Yeah,
and some of my background stuff, we did a lot of habitat restoration stuff, and that's really important when you've had land that's been used for other things, and you're trying to restore that back to make sure that you're getting suitable habitat for the native plants that were there before. And so I think that, like you said, it covers such a wide range of applications.
Yeah, exactly. Yeah, so I think there's a lot of opportunity out there for use of tools like the PARIO. And it just depends on what you're trying to look at.
Okay. Next question. How long does a PARIO measurement take, and how many PARIOs can you hook up to one computer?
Shaun, I'm going to let you take this one.
So this is a great question. I think one of the exciting things about the PARIO is that it is a lot shorter, the actual measurement time. Right now, the measurement time takes anywhere between about 2.5 to 3 hours. That doesn't include you still need to do the same kind of pre-treatment stuff that we do with all the other applications. But once that's all ready and plugging it in and starting it, it's about 2.5 to 3 hours before you take a small sample and you put that in the oven, the oven overnight. And then you still have to do your sand sieving, just like with any other method. So there's definitely time, and that time is going to vary based on your soil for that pre-treatment and that post-treatment. But the actual measurement is actually really quick.
Yeah, which is pretty crazy to think about. I mean, for those, a lot of us have gone out and done the traditional hydrometer method, the 24-hour measurement, and we all know how long that takes. And the fact that we can get better accuracy, a plus or minus 0.5% accuracy, in just a little over 2 hours is pretty amazing. And so it's pretty neat to think that we can do that. I think on there, how many PARIOs can we hook up now to a computer?
With our new LabRose Soil View software, you can put 20 units up. I do want to say on there that if you are putting more than about 2, you want to make sure you're using a powered USB hub, because it does pull usually too much power for a normal USB hub, and you'll lose communication.
Yeah.
The software will support up to 20.
It's a lot of soil texture and analysis measurements.
Yeah.
All right. This next question asks, what about the pre-treatment of samples? Any advice for the organic matter destruction?
Yeah, well, great question. And I just want to start off by saying that pre-treatment is still by far one of the most important steps that you're going to take in order to get an accurate particle size analysis measurement. Because if you don't pre-treat your samples well, then you're going to have samples that are either bound together or other things that could interfere with the measurement. So they're super critical.
That makes or breaks your measurement, absolutely.
Yeah. So when we're thinking about pre-treatment, there's 3 main areas that we need to pre-treat. It's dispersion, and then iron oxides, and organic matter, right? I'm probably missing some other stuff in there.
So currently we list the salt destruction as an optional one, and iron is going to be very dependent on your soil as well.
Right.
But one thing, or 2 things, I guess, that everybody needs to do are that dispersion and the organic matter destruction.
Yep. Yeah, those are the most important. And there are several different ways to approach, especially when you're thinking about dispersion and organic matter destruction, although I think the organic matter destruction, there's one primary way to do that with hydrogen peroxide. But pre-treatment, like for the dispersion, there's typically you need to do 2 steps. You have the physical and the chemical dispersion, and you always start with the chemical dispersion. We typically use sodium hexametaphosphate. There are other dispersants out there that people use as well. There's ASTM methods, and then there's DIN methods as well that sometimes slightly differ. And then methods of soil analysis has, I think, some different options in there as well. I think sodium in the U.S., sodium hexametaphosphate is probably the most common that I can think of. That's what I've used. And then for physical dispersion, we use either a shaker table or the milkshake mixer approach. So. And then I don't know, Shaun, what about organic matter?
I've always done the hydrogen peroxide because I think it does a better job, and it also kind of leaves your soil more in a natural form than baking it or things like that.
Yeah.
Some people like to bake it to kind of burn off that organic matter. In some soils, that can kind of lead to some hydrophobic behavior, which I don't like to see. So for me, it's always been hydrogen peroxide. In places, in soils that do have a high organic matter content, then that can get messy and take some time.
Yeah.
But I think just being there and making sure you're keeping an eye on it usually takes care of all those issues.
Yeah.
So.
Yep. No, definitely got to take care of that. I can't remember what is the minimum. Is it 1.5% organic matter that?
Yeah.
You could, if it's below that, then you don't have to pre-treat for organic matter. Yeah. In most soils, hopefully we have more than, especially at the surface, hopefully we have more than 1.5%. But in many cases, we do see soils that don't have that.
And I think for me, just as a best practice, it's good to just do it anyway.
Right.
Because I want to make sure that if I'm spending the time to do all this pre-treatment and take the readings, that I want them to be as accurate as possible.
Yeah. Take the time, patience.
Yep.
All right. This next individual also is asking about dealing with organic matter with hydrogen peroxide. They're having challenges with that kind of pretreatment as well. Do you have any insights? They are asking specifically for working with volcanic areas with very clay soils. So any thoughts or insights or help for them?
Yeah. I mean, again, it's the method that you have to work with the soils. But the big challenge with volcanic soils is not just the pretreatment, but that the soil actually has some physical differences. Volcanic soils tend to have more allophane content in the minerals, or more allophane as a mineral. And because of that, they are actually, their physical characteristics are different. Your particle density is different, and so you have to account for that. But outside of that, I think there's really no better way for the pretreatment than the peroxide and maybe the burning. But
yeah, I think from my experience with some volcanic soils, there's been very little organic matter content left in those for the most part. So I haven't had a lot of challenges with that personally. We did a little bit of work with some volcanic soils from around Mount St. Helens when I was doing undergrad stuff, and so those ones, they didn't have a lot of organic matter in those ones that were the purely volcanic stuff. So I think just doing that hydrogen peroxide and keeping an eye on it is kind of what you got to do.
Yeah, we didn't have to deal with volcanic soils in Texas, so it's more of a Washington thing.
Yeah.
All right. This next one, are there any scanning techniques available for texture analysis?
Yeah, that's a great question. I guess it depends on what what you define as scanning.
Mm-hmm.
I mean, the laser diffraction is I guess would technically be a scanning method.
Yeah.
And it definitely works well. One of the challenges with laser diffraction, though, is clay particles are not round; they're flat, and depending on the angle at which the laser is looking at the clay particle, it could induce some error in your clay fraction analysis because it's going to look like a bigger particle than what it actually is. But that's a common scanning technique, I guess, that I could think of.
Yeah. As far as, I'm not sure if they're asking about remote sensing, but as far as remote sensing goes, there's really not a good method for doing texture analysis remotely. Especially in places where you do have a lot of different soil types really closely related or at different depths.
Mm-hmm.
There's just really not a good way to do that in a remote setting.
Yeah.
All right. Next one. Can we use, speaking of remote sensing, can we use satellite-derived products or Vis-NAR spectroscopy with the same level of confidence as a pipette method? Which method is going to be more popular in the future?
Ooh, that's a good question. I am not aware of any satellite-derived products that we can use to estimate soil texture. Maybe there's some out there that I'm not aware of. I'm not an expert in satellite measurements. Vis-NAR for sure can be used to make these measurements, but you cannot have the same level of confidence. And when you say confidence, it's accuracy as a pipette method. But it's a great tool for quick analysis and quick scanning of soils to get some of those properties. Vis-NAR depends on the model behind it, just like a lot of these optical methods like that. But it's a good approach. So
I think in the future we're probably going to see more of that being used, but I think that we're still going to be using these traditional methods as well to kind of ground truth the things that we're seeing on there. We see that a lot even now with satellite imagery of other measurements, other environmental measurements. We look at these and then we still want to make sure that we're actually seeing accurately on the level that we want to see by ground truthing it with other sensors. So
no, I think we're seeing a lot of use of some of these methods, Vis-NAR, and I think it was mid near infrared measurements as well. You're seeing a lot of use of that for these types of measurements, and they are super powerful tools because you can do a lot of measurements really quickly. Again, they're never going to I don't anticipate they'll ever have the same level of accuracy that you can expect from some of these traditional methods. But again, I'd love to be proved wrong and see some of these methods turn out to be more accurate than what we foresee them being.
All right. I think this is going to be our last question for the session here. And they are asking, what do you guys do with saline soils with particle sedimentation due to flocculation generated by excess salts?
Great question. I'm going to let Shaun take that one.
So we do have, that's one of those 4 areas that Leo was talking about earlier that we do pretreatments for. If your soil has a lot of salts in it, there's a section in the manual that does talk about removing salts. And the basic structure or the basic process is that you're just going to be rinsing the soils, putting it into a centrifuge to kind of pull that water out of the soil matrix there. And you're going to do that a couple of times until that EC, the electrical conductivity of that liquid, is down to an acceptable level. That's basically what you're going to do. I do want to kind of put a little plug in here. We are getting some videos for these pretreatment methods that we're making right now. I'm hoping they're going to be out here in the next couple of months, maybe by the first of the year, that kind of go over these processes that we're talking about. The manual is very detailed and has really great information on this, but having a little video to go along with that's always a good help.
Yeah. It's a lot of these things can be dealt with. They're correct pretreatment.
Yeah.
But sometimes you just have to be patient and take the time to do the pretreatment, which sucks sometimes because it is, it's more work you have to do to get to these measurements. But we want to be accurate with our measurements, so let's take the time to do the work that needs to be done to get that way.
Absolutely.
All right. Any final thoughts or insights on soil texture analysis, you guys? Things that we missed or didn't cover?
I don't think we necessarily missed anything. I just, I can remember back to doing hydrometer measurements in grad school and trying to process several hundred samples and what that was like. And these tools have come a long way. And it's fun to work on these things and see where we're going to go. I'm really excited to see where we continue to push these tools in the future. We have lots of crazy ideas on how to continue to improve these measurements. And that's a fun part of what we do here is experimenting and trying to make these measurements better.
Yeah. And I would just add that, we do really love this stuff. So if you have questions or data that you want to send and have us look at, we're always happy to do that. We do really enjoy this. And I think getting really accurate measurements and getting these really detailed readings can really help your research or your whatever it is that you're working on. Yeah.
All right. That's going to wrap it up for us today. Thank you again for joining us. We hope you enjoyed this discussion. Thank you, everybody, for the great questions. And again, if you have any questions that we didn't answer, please contact us via our website, metergroup.com. Finally, you can subscribe to the Meter Group YouTube channel and accept notifications to see previous episodes of Office Hours and to get notified when future videos are available. Thanks again, stay safe, and have a great day.